450 light-years away, in a quiet, undisturbed corner of space called the Taurus molecular cloud, something violent is being born. We know it's there, but the event itself is wrapped inside a thick, opaque band of cosmic dust. This is a system known as HH30. If you look closely at the edges of that dark band, you can see the faint glow of starlight bleeding out from the top and bottom. For decades, these stellar nurseries frustrated astronomers. The dust here is so dense it physically stops visible light from escaping, hiding the mechanics of star formation from our telescopes. To understand what is happening inside HH30, we have to find a way to cut through that darkness. Because hidden in that cloud is the raw, unedited blueprint of a new solar system. Usually when we look at young star systems, we see them from above. That top-down angle means the blinding glare of the central star washes out the subtle details of the disk around it. HH30 is physically tilted relative to Earth, aligning perfectly edge-on to our line of sight. This model demonstrates how the geometry works. By looking at it edge-on, the thin outer rim of the disk physically blocks the intense glare of the star at the center. With the light blocked, we get a clean, undisturbed cross-section. We can observe the distinct vertical layers of the dust band itself. This geometric alignment turns HH30 into a pristine natural laboratory, allowing us to map the precise anatomy of planetary birth. To take advantage of that angle and map the entire system, astronomers pointed 3 highly specialized telescopes at HH30 at the exact same time. The very first observation came from the Hubble Space Telescope. Operating in visible light, Hubble captured the exhaust. It revealed twin jets of gas blasting from the hidden star's poles, illuminating the surrounding darkness. To see deeper, researchers turned to the James Webb Space Telescope. Webb uses infrared sensors, which are capable of penetrating the dark, outer layers of the dust cloud, where visible light gets trapped. Through that infrared lens, Webb detected a scattered fog of tiny dust grains, many no larger than bacteria, floating suspended in the upper atmosphere of the disk. Hubble mapped the violent exhaust. Webb exposed the microscopic atmosphere. Mapping the complete system requires layering these distinct spectrums. The final piece of the map came from an observatory back on Earth, the ALMA radio array in Chile. ALMA is specifically tuned to radio wavelengths. This allows it to punch right through the absolute densest, most opaque regions of the cloud that block both visible and infrared light. In those deep, hidden regions, ALMA detected larger, millimeter-sized grains that completely eluded other telescopes. These heavier grains were sinking downward, settling into a razor-thin seam perfectly aligned along the central plane of the disk. This composite diagram stacks the observations. We take Hubble's polar jets, layer in Webb's scattered upper fog, and finally anchor it with ALMA's dense central seam. This gives us an exact anatomical map of a newborn star system. The complete structure only comes into focus when multiple instruments work together. That deepest layer, the razor-thin central seam discovered by ALMA, is where the real physical work of the system happens. Inside this high-density seam, the dust grains stop floating freely. They are packed tight enough that they physically collide, stick, and bind together. It is a steady mechanical chain reaction. The microscopic grains clump into pebbles, and those pebbles slowly accumulate into massive boulders. This dark, hidden seam is an active forge, gathering the raw material that will eventually form entire planets. All of this planetary construction is happening quietly, completely obscured right now within the vast darkness of the Taurus molecular cloud. By combining the data from these 3 telescopes, we are watching a live replay of the exact mechanical process that built Earth billions of years ago.